5. So all of these work. They're tried and true. We're not going to prove them right now, but they are 100% true. Be careful of your pluses and negative signs. For instance, on this sign, if you pick the positive one, that means you're going to pick the top one throughout. So if I have sine of a plus b, I'm going to use plus on this side. However, for cosine, if I have a plus b, I'm going to stick with the top one, so I'm actually going to subtract on this side. So for sine, our signs stay the same. For cosine, our sign is going to switch when we're doing our adding and subtracting or summing differences. Tangent is just a beast on its own. It is this full equation where if I have a plus b, I'm going to have tangent a plus tangent b on top. But on bottom, I'm going to have 1 minus tangent a times tangent b. So just make sure the sign on top goes with all the signs on top on the other side. All right, any questions on that? Seems pretty easy, right? It is. If you remember a formula, it's just kind of plugging and chugging. A lot of times our hardest part is breaking apart into two things that I know the answer to. So let's just go, we'll roll into an example, because they'll make a lot more sense once we actually do an example. Tangent of 7 pi over 12. You take out your unit circle. Wait, actually just go ahead and make sure you have a unit circle handy, because we are going to need it. But you're going to realize that 7 pi over 12 is not on our unit circle. And you don't need your unit circle if you know the unit circle. Yeah?
Wait, could you just like subtract 2 pi from it? Or does it not?
No. You can't just subtract something from it.
Or do you like to find like the something angle?
Like a coterminal angle or something?
Yeah.
Not quite. We are actually going to rewrite 7 pi over 12 into two angles that are on the unit circle. Kind of like how in my example, if I gave you 75 degrees, you would rewrite it as 30 and 45 because those are on my unit circle. Radians are a little tougher. So my hint to you to find those angles that add together to give you 7 pi over 12 is give yourself a little bit of workspace. So I'm going to do this. I'm going to give myself some workspace. And I'm going to pick out the main 3 angles that are on the unit circle. Just the first 3 because those can usually help most of them. So our main first 3 important angles are pi over 6, pi, maybe, pi over 4, and finally pi over 3. What popped up? Oh. Those are the main ones I know for sure exist on my unit circle. So those are the first ones I'm going to check. Well, I need 2 angles that either add to 7 pi over 12 or subtract to 7 pi over 12. So the easy way to picture that is just to rewrite our denominators as 12 so I can see what the numerators would look like if I added them. So I'm just going to rewrite pi over 6 as just 2 pi over 12. I'm going to rewrite pi over 4 as 3 pi over 12. That's a 13. That's a 12. And finally, we're going to have pi over 3 is the same thing as 4 pi over 12. And now I'm just picking 2 of those that either add to 7 pi over 12 or subtract to give me 7 pi over 12. Yeah?
Pi over 3.
Yeah, we're just going to add pi over 3 and pi over 4. I'm going to go through a couple extra steps here because it's always nice to know this stuff in our notes. So that tells me that 3 pi over 12 plus 4 pi over 12 does in fact equal 7 pi over 12. But rewriting these in their original things, we could just have pi over 4 plus pi over 3 equals 7 pi over 12. So that means I can rewrite 7 pi over 12 as just pi over 4 plus pi over 3. So we started with tangent of 7 pi over 12. That's going to be the exact same thing as tangent of pi over 4 plus pi over 3. I really didn't do anything crazy yet. All I did is I rewrote 7 pi over 12 is pi over 4 plus pi over 3, because I know those two things are on the unit circle. So nothing new happened in this step. I just broke it apart into something a little smaller. Just like 75 is the same thing as, is that what I picked earlier? I just want to double check. Yeah, I picked 75. It's the same thing as 30 and 45. Same thing, just rewriting it. All right, but now what we need to do is we need to know these sum and difference formulas. This one's plus. I have something plus something. This is my first term. So you might say this is your A term, I guess. And maybe you say this is your B term. With adding, it really doesn't matter, but with subtracting it's going to be really important. But just know what one your first term is and your second term. And then we go back to our possible sum and difference identities. Well, it's obviously tangent. It's plus. So we're going to have tangent of our first term plus tangent of our second term in the numerator. And on the bottom, we're going to have 1 minus tangent of our first term times tangent of our second term. So let's go ahead and write that down. So we're going to have tangent of our first term, which is pi over 4, plus tangent of our second term, which is pi over 3, all over 1 minus tangent of our first angle, which is pi over 4, times our second angle, which is pi over 3. And now, lo and behold, every one of those values is on our unit circle. Every one of those values is on our unit circle. Can someone tell me what tangent of pi over 4 is? Is one of the easier ones. Yeah?
No, wait.
No, hang on.
1.
It's 1. There you go.
Yeah.
Yep. And the way I always remember it is at pi over 4, it's that middle one, so it's square root of 2 over 2 divided by, oh, it's got to be 1. Yep. So we have 1. The only other thing we have to get is tangent of pi over 3. And who's got tangent of pi over 3? That one is a radical 3. And what I have on top is just what I'm going to do on bottom. So we're going to have 1 minus tangent of square root of 4 is just 1 times square root of 3. Because tangent of pi over 4 is 1, tangent of pi over 3 is square root of 3. So all the heavy lifting is done, however this is not simplified. There is a square root in the denominator. And I can't multiply by just square root of 3 on the bottom because it's going to remain there. What do I need to multiply by? Yeah.
The entire 1 minus radical 3.
Close.
1 plus radical.
1 plus radical 3. We're going to multiply by the conjugate. The conjugate is what we're going to multiply to simplify. So I'd multiply the bottom by 1 plus square root of 3, which means I have to multiply the top by 1 plus square root of 3. Maybe I'll put this in parentheses and this in parentheses so I can remember to distribute fully. All right, on top, I'm just going to distribute this 1 to everything, so that'd be 1 times 1. You can use FOIL. You can do whatever method you want to. It is a plus and a plus, so there's a nice pattern there. But I'm just going to do the full thing like I forgot stuff, so we'll have 1 plus square root of 3 plus square root of 3 plus 3. All over the bottom's a difference of squares, so it's going to be 1 squared minus square root of 3 squared. That's why the conjugate always gets rid of the radical. All right, that's just going to equal, I got 2 square root of 3 plus 4. All over, well, that's just 1 minus 3, which is negative 2. We can go a little further. I'm going to break it apart. You can probably do in your head, because it really is 2 square root of 3 divided by negative 2. and 4 divided by negative 2. So most of the time I don't split it apart, but we will for this case. So it'll be 2 square root of 3 divided by negative 2 plus 4 divided by negative 2, which is just going to equal a negative square root of 3 minus 2. Yeah.
Does it matter what order the answer goes in? If there's negative 2 minus right?
Yeah. So it depends on what book you're reading it. Sometimes they like the radical first, and sometimes they like the radical second. But I don't really care which order you give it to me in, because it's the same number. Multiplying wise, I like the number up front and the radical next. But in adding and subtracting, I'm okay with. So you could have this, or you could have negative 2 minus square root of 3. Yeah. Yeah.
How did you go from 2 squares of 3 plus 4 over negative 2 to 2 squares of 3 over negative 2?
Do you see how this is the exact, like, remember when you add fractions? You just add the numerators? So I just split this apart into 2 fractions. As one of the steps we did in,
The last thing, yeah.
Because when I combine these back together, right, I would have 2 square root of 3 plus 4 all over negative 2. Well, that's what I had. Alright, I'm just going backwards. I just know I'm dividing everything by negative 2.
Okay, and then you divided it.
Yep.
Instead of doing it.
So sometimes when I'm doing it in my head, I just say, okay, divide that by negative 2, divide that by negative 2.
So you can technically just skip that next step and go to the...
Yeah, you can go right to the answer. Yeah. And a lot of times in my head I can see that 2 square root of 3 plus 4 divided by negative 2 is just going to be negative square root of 3 minus 2. Yeah.
So you multiply by the conjugate because you multiply by the radical because it's still have another radical in there.
Yeah, because if I multiplied by square root of 3, it just would have moved it. And you'll find yourself doing that sometimes. You multiply the radical and all of a sudden you just moved it to the other side, but it's still in the denominator. That tells you need to multiply by the conjugate. Yep. That's absolutely why I multiplied by the conjugate. Alright, so oddly enough, the hardest part about this was simplifying, right? The rest was just, can you rewrite 7 pi over 12 using just these 3 things? And then just plugging it into an equation that we have to have memorized. Okay? There's no easy way to memorize these a lot of times. It's just straight up memorize them. Alright, there's no fancy tricks. Like with the Pythagorean triple ones, where you just find sine squared plus cosine squared equals 1 and divide by sine, divide by cosine. There's no nice little trick for these. But are there any questions on any steps I did? Tangents are usually the hardest ones. Alright, you'll see when we do the cosine one, it goes a little quicker. Yeah?
Oh, never mind, sorry.
You sure?
Yeah.
Okay. Do you want me to leave it up for a minute?
No, that's okay.
Okay. You sure?
I just didn't realize why you used which, or specifically the tan equation, but then I saw that it says tan.
Oh, okay. I picked it because it told me it, yeah.
Makes sense.
Like this one, we're going to use the cosine one. I know, mind blowing, huh? Alright, we are going to use the cosine one. I put the cosine ones right above. The thing about cosine is, if I'm adding 2 angles together, I actually subtract it on the other side. So if I have cosine alpha plus beta, I actually use subtraction on the other side. If I use subtraction for my angles, I actually use addition on the other side. So once again, you could do this in your head a lot of times once you get good at these angles. But I'm just thinking about 3 possible angles. I'm thinking about, and sometimes you have to expand your search. All right, sometimes you have to expand your search to ones that might pi over 2, 3 pi over 2. You might have to expand your search. This is just, it's a nice small one. So let's think about our main one. So that's pi over 6, pi over 4, and pi over 3 are our main guys. Well, my denominator is 12, so to figure out if I'm adding or subtracting, I need to have denominators of 12. So we are going to have 2 pi over 6 of 3 pi, not over 6, scratch that, over 12. I'm going to have 3 pi over 12. And finally, I'm going to have 4 pi over 12. Now I either need to add two of them together or subtract them to give me out pi over 12. How could I do that using addition or subtraction? Jack?
You could either do pi over 3 minus pi over 4 or pi over 4 minus pi over 6.
Yeah, you could do either one of those. You could pick either one. I'm going to pick the same one I did in the last class. That way it just matches between the classes. Now I just got to figure out which one I did in the last class. So I picked the pi over 3 minus the pi over 4. In other words, I picked kind of the same ones again. I picked these two guys, which I just said as, 4 pi over 12 minus 3 pi over 12 equals pi over 12. But a better way to write that is 4 pi over 12 is pi over 3 minus pi over 4 equals pi over 12. Bless you. I see I dropped a, there we go. Alright, so sometimes you have to do a little side work. And I'm not going to lie to you, there are times where you have to expand your search beyond these. Like I said, you might have to throw a pi over 2 in there. You might have to throw a 3 pi over 2. You might have to expand your, it's just nice to start with those first three, see if it works, and then expand your search. Alright, so we are using pi over 4 and pi over 3. Make sure you write it in the correct order. Alright, so we have cosine of pi over 12. I'm going to rewrite that as cosine of pi over 3 minus pi over 4. It's very important that you write them in the proper order because one is our alpha and the other one is our beta. And it matters what order I put it in. Alright, so I have an angle minus an angle. That sure looks like this one. So we're doing cosine times cosine plus sine times sine. Alright, so we're just going to rewrite this as cosine times cosine. So cosine of my alpha value, pi over 3, times cosine of my beta value, pi over 4. And subtraction tells me to add. Uh-oh. I'm going to run right into that guy. I wrote a little too big. Let's slide that down a little bit. We should have room. There we go. Plus sine of our alpha, which is pi over 3, times cosine of our beta, which is pi over 4. Good thing is hopefully we know our cosine and it should have been sine. Sine of pi over 4. I can't remember if I said it or I just threw myself off at some point. Now we just plug in our values. Alright, we use our memory or we use our unit circle. Hopefully you're using your memory somewhat to come up with these values. But you should come up with the cosine of pi over 3, that's our third one, is going to be 1/2. Cosine of pi over 4, that was a nice one because it's just square root of 2 over 2. Plus sine of pi over 3, well sine of pi over 3 is square root of 3 over 2. Don't take these numbers on faith, you should be checking on your own too. And finally we have the sine of pi over 4, which is square root of 2 over 2. Don't forget how to multiply fractions. When you multiply fractions, you multiply the numerators and you multiply the denominators. So this is just going to equal 1 times square root of 2, which is square root of 2, over 2 times 2, which is 4, plus square root of 2 times square root of 3 is going to be square root of 6. Quick refresher, if I multiply square roots, we just multiply the numbers underneath the square root, so I have 2 times 3, and we put it all underneath the radical. And then finally we have 2 times 2, which equals 4. These are two fractions with a common denominator, so we just add the numerator, so we have square root of 2 plus square root of 6 all over 4. There's absolutely no way to simplify that, so we are done. There's no radicals in the denominator. You can't push those two radicals together, so you are done. We're not going any further than that. Questions, comments, concerns? Do any of these steps not make sense? This can get tricky because there's a whole bunch of stuff happening here. It looks like there's a lot, but it's all just little bits added together. Right? We know how to find the cosine of pi over 3. We know how to find the cosine of pi over 4. It's just putting it all together into this equation that causes a lot of headaches. We're good on that answer? Do the next one. You are in charge of the next one, mostly because degrees are a little easier. They're a little easier. So you're looking for degrees that are on your unit circle that when added or subtracted give you 15 degrees. So you're thinking about maybe 30 degrees, 45 degrees, 60 degrees, 90 degrees, 3 billion degrees. It should look similar to the one above it.
Okay, so what would be a change if you did different?
Nope. Surprisingly, no matter what angles you pick and how you do it, the answer is always going to simplify to the same. Right? It's just a matter of simplifying.
Should be converted into
Could you have converted it into what? I'm sorry.
pi value.
Oh, could you have converted it into, yeah, you could have. You would have came up with the same answer. Yep. There's a bird in the room. A bat. That's scarier. Maybe I taught you completely wrong on everything we've done. There's no such thing as a unit circle. It's just a big psychological experiment on high school students. Alright, so I picked 45 and 30 degrees. I said 45 minus 30 degrees equals 15 degrees. You could have picked something different. You should have came up with the same answer when simplified. So I said sine of 45 minus 30 degrees. Hey, that equals sine of 15 degrees. Well, sine is sine cosine. And since we're subtracting, I put a subtraction sign in between. Sine, our subtraction stays the same. So sine of our first term is sine of 45. Cosine of our second, 30 degrees. Cosine of our first angle is 45 degrees. Sine of our second angle is 30 degrees. Then I just found the values, multiplied, and simplified. Yeah?
Is it okay if I did this with pi over 12?
Like just
Yeah, but it's just a conversion.
Yeah, is that fine?
As long did you get that answer?
Well, like, I'm on my way to that answer.
I think it's easier if it's in degrees just to leave it in degrees, but if you did that, you'll come up with, as long as you come up with the right answer. I'm not overly concerned. I would leave degrees as degrees because degrees are pretty easy numbers to deal with.
Yeah, I didn't really realize we could do that.
Yeah. Do you want me to keep this up there or go back to it later?
Yeah.
I'll just go back to it later.
Okay.
I'll go back to it after this other one because cofunctions aren't going to take a long time to go through. So cofunctions. Remember on the unit circle? Did you have a question? I'm sorry.
Oh, I can just ask it later.
Oh, we can ask it right now. Is it on this?
Yeah, no, I was just wondering why, like, you kept it separate in one, or, like, separated it in the other one, and then didn't here. Like, couldn't you just leave it at square root of 6
Minus.
over 4 minus square root of 2 over 4?
So this is a more, I think I know what you're talking about. Okay, so this is more, if you could push it together, it's more simplified if you have a fraction.
Okay.
Okay, but what I realized on the tangent one,
Yeah.
we're going back to that one I think, right?
Yes.
Notice how when I split it apart, I could simplify each thing, I can get rid of the fraction.
Yeah.
If you can get rid of the fraction, that's more simplified.
Okay.
If you can't, combining it is the most simplified form. All right, but don't waste a whole bunch of time figuring out what's... The meat and potatoes of this is honestly right here.
Okay.
Everything else is just the gravy on top. All right, and this is just the cherry on top. Ooh, mashed potatoes and gravy and a cherry. But this is the did you fully simplify it? Awesome. Otherwise, I'm more looking for, can you get here?
Okay.
Can you attempt this? All right. Cofunctions. Cofunctions, identity, comes from the fact that, hey, did you ever notice, like, if I take the sine of 30 degrees, it's the exact same thing as the cosine of 60 degrees? So if I just shift my unit circle a little bit, I can get from sine to cosine. And that's where we have these cofunction identities. That means if I have sine of pi over 2 minus some number, it's the exact same thing as if I just take the cosine of that number. And all of these are true. We're not going to go through each one. But I think it's a lot easier if you can kind of see an example of it. So it says, use cofunction identity to find the exact value of sine. I will tell you to use cofunction. All right? Do not try to use cofunction. Try to use the adding and subtracting, the sum difference ones, when I ask you to find the exact value. All right? Cofunction, you'll know we're doing cofunctions because I tell you to. All right? But it says use the cofunction identity to find the exact value of 5 pi over 12. So what I'm going to do is I am going to use this identity here, this sine of u equals cosine of pi over 2 minus u. So that allows me to rewrite this. So the book gave me sine of 5 pi over 12. What I'm going to spit out is the fact that that's the same thing as cosine of pi over 2 minus that same thing. Per this. Notice this u is just this. All right? This 5 pi over 12 is the same thing as going cosine of pi over 2 minus the 5 pi over 12. So this is kind of like my u. And per this, I can do that. All right, let's go ahead and simplify that. Well, to subtract, I would have to have a common denominator. So let's just change this to 6 pi over 12 minus 5 pi over 12. That equals pi over 12. So this is the exact same thing as cosine of pi over 12. Now you're going to tell me that pi over 12 is not on the unit circle. But bear with me, I'll come back to this slide.
15 degrees.
Is 15 degrees, or cosine of pi over 12 is square root of 2 plus square root of 6 over 4. All right, I'm not going to have a problem where you do the cofunction to this, but that's where I got that answer from. So I got that equals square root of 2 plus square root of 6 all over 4, and that was just from example, and I would put this down in my notes, example 2. Because I'm one of those people that would put this answer, and then I would study it like a week later and be like, how did I know that? So just put down the guy from example 2. All right, that's cofunctions. In the homework, you just have to fill in the blanks on the cofunctions. And I will go through the homework really quick with you, just so you're not doing too much work, because some of them should be really easy. First ones are actually solving them. So you should come up with like a number answer, like square root of 2 minus square root of 6 over 2. 5, 7, and 9. You should just have something like cosine of 70 degrees. You shouldn't simplify it any further than that. All right? So you should have like cosine, cotangent, something like that. 11, 13, 15, 17, you should have a numbered answer. Number 19 and 21. Don't overthink those. It is honestly just do pi over 4 plus pi over 3 and you're done. All right, no simplifying from there. There's not a lot of room, so you shouldn't have to do a lot of work to add pi over 4 plus pi over 3. And 23, 25, 27, and 29 is just using those identities, but backwards. All right, because you don't know the sine of 23 degrees, so you're not plugging your calculator, you're just going to do it backwards. All right, so you're going to use those identities from the beginning to basically say, hey, if I give you this, you can rewrite it as this and simplify from there. All right, go ahead and get started. I will go back to that slide, Nick. Was it this slide?
Yep.